Okay, so in this series of videos, we're going to be looking at rates and ratios. Now, I'm not going to be going through a lot of the definitions or a lot of the theory. I'm basically just going to give you a quick overview and just get stuck into the question. So we're going to be looking at what are rates and ratios. We're going to be looking at the common examples. We're going to be looking at some medium level questions, and then we're going to get stuck into some of the harder questions that you guys will be seeing. All right, so let's start off with rates. Now, what is a rate? Now, a simplified version of what a rate is an amount per unit. So, for example, kilometers per hour. Now, you would have seen this if you guys ever drive or have ever been driven, and you'll notice that on the car there's this speedometer, and you'll notice that that's what tells how fast you're going. So, 10 kilometers an hour, 30 kilometers an hour, 90 kilometers an hour. Another example, lollies per student. So how many lollies does every student receive? Another example is the price per textbook. Now these are all rates. Now let's have a look at expressing an expression as a rate per unit. Example number 1, John travels 5 kilometers in 5 hours. Express his speed in kilometers per hour. Now I want you to go back and let's have a look at this. John travels 5 kilometers in 5 hours. What I want you guys to think of is, see this part over here in 5 hours? I want you to think of this as the rate. So now the question says, express his speed in kilometers per hour. So originally, he travels 5 kilometers every 5 hours. And the question wants us to express it in kilometers per 1 hour. Now let's see how we got to the 1 hour. Well, have a look at the hours first. How would I go from 5 hours to 1 hour? I would have to divide that by 5. Because 5 divided by 5 gives us 1. So therefore, I should also divide this by 5 as well. So therefore, our final answer would be 1 kilometer per hour. Example number 2. Jane is a painter and paints a space of 100 meters squared using 14 liters of paint. So far we know that for every 100 meters squared, she's going to be using 14 liters of paint. So I want you to think about this. What if she was to paint an area that was 50 meters squared, so half of the 100 meters squared? Well, that means she would need half of the paint used. So she'll only need 7 liters of paint. What about if she was to paint 200 meters squares of wall? Then that means she'll need double that. So I want you guys to start thinking about these questions logically. And the question says, how many meters squared can she paint with 1 liter? So now, in other words, we have to get this 14 liters and we have to get that down to 1 liter. So this is how I want you to think about it. How do I get this to 1 liter? And the only way to do that here would be to divide by 14. So because it's an equation, we got to do it to both sides. So divide by 14 and also divide by 14. So we're left with 100 meters squared divided by 14. That should equal to 14 divided by 14. And now we would get 7 meters squared is equal to 1 liter. So another way to just rewrite this would be 7 meters squared per liter. Okay, now the next thing that we need to know with rates is how to convert rates. But before we do, we have a few prerequisites. And what these are is we need to know how to convert from units to units. So, for example, if we were to have a look at length, if I wanted to go from millimeters to centimeters, I would divide by 10, centimeters to meters, divide by 100, and so on and so on. So this is all up here for you guys. I'm going to leave this up here so you guys can copy it in your free time, pause the video, do whatever you want. Some of you guys will probably even know these ones, but I'm just going to quickly go through some of them here. Having a look at area. Now, just as the previous question that we saw, the area was measured as units squared. So the one that we had was meters squared. Now, what it is it's exactly the same as the length units, but now we're dealing with area, we're going to square all of those. So what that means is from millimeters to centimeters, I would normally just only divide by 10. But because we're dealing with area and because the unit is squared, I'm going to have to divide by 10 squared. And as you can see, that's the reason why I had like a little bracket around that, and then I squared all of them. Same thing with volume. Volume is measured in cubic units, so that's why we're going to be dividing by 10 cube, dividing by 100 cube, timesing by 1000 cube, and so on and so on. Okay, so here's all the conversions. I'm not going to go through them. They're pretty straightforward. So I'm going to give you guys a couple seconds. You guys can pause the video and you guys can, if you like, just jot all this down. Okay, so now let's have a look at converting rates. Example number 1, 40 kilometers per hour to meters per second. Now, let's rewrite this and let's analyze it a little bit in more detail. Now, this is the way I want you guys to think about it to help you out a little bit more. This is the unit, and I want you to think of this to be the rate. First, convert the units. So, the units that I had was 40 kilometers, and I need to convert that to meters. So I've got to ask myself, okay, kilometers to meters, that's multiplying by 1000, so that means 40,000 meters. So for step number 2, I would like to rewrite the new rate just so I know everything what's happening in front of me right now. So now the new rate is going to become 40,000 meters per hour, and I have to convert that to meters per second. Okay, so now look at this. This is in meters, and now that's in meters. And now it's time to convert the rate. Okay, so the way I like to think about it is very simple. If you have a big rate and you want to go to a smaller rate, I'm going to divide. And the reason for that being is because if you have a look, think of this like a big chocolate block, whatever you want to call it. And because I want to get it to a smaller block, I'm going to be dividing that. And then what happens when I want to go back the other way? So if I want to go from something small to something big, I'm going to be multiplying it. So that's just my personal preference. Again, that's the way I like to think about it. It makes more logical sense to me. Now let's have a look at the question again. So therefore, 40,000 meters per hour to meters per second. Because I'm going from hours to seconds, well, that's a big rate to a smaller rate, which means I'm going to be dividing. So now the question is, how do I go from hours to seconds? So 40,000 meters, when we divide it by 60, we just now went from hours to minutes. And now from minutes, we got to go to seconds. So we have to divide by 60 again. So our final answer here is going to be 11.11 meters per second, provided that you've put everything right into the calculator. Okay, so just a quick recap. Number 1, whenever you want to convert any type of rate, no matter what it is, first convert the units. So that'll always be the first thing that comes up in the question. So in this case, it was 40 kilometers, and we had to convert that to meters. So first convert the units, whether you need to divide or times, whatever the case may be. Number 2, rewrite it just for your own sake, just so you're following your train of thought. Then number 3, ask yourself, am I going from a big rate to a small rate, or am I going from something small to something big? So if I was going from minutes to days, I'm going from something small to something big. So I'm just going to be multiplying by whatever the converting rate is. Okay, so in example number 2, Bolt runs 11 meters in a second. How many kilometers can he run at this same speed every hour? So let's look at what we have so far. So we have that Bolt can run 11 meters every single seconds. So every 1 second he's doing 11 meters. So for example, in 2 seconds he'll do 22 meters. Okay. How many kilometers can he run at this same speed every single hour? Okay, so now the question is saying he can run at 11 meters per second, but now they want it is how many kilometers can he run? So now it's going to go to kilometers at this same speed every hour. So now, in other words, they want his speed not in meters per second, but in kilometers per hour. And so that's how you dissect the question. So you know what the question wants. Kilometers per hour. Okay, so we've got our little table on the right just to help us out for a few more questions, and then we're going to be independent of that. So let's have a look. So first, convert the units. So the units would always be what's in front. That's the way I like to just think about it. So we've got to convert 11 meters to kilometers. So now, what's the conversion from meters to kilometers? Well, that's going to be dividing by 1,000. So we need to divide by 1,000. So that's going to be 11 over 1,000, which is roughly 0.011 kilometers. Not roughly. So, which is going to equal to 0.011 kilometers. Okay, now let's rewrite the new rate just so we're keeping track of things. So now we just converted the meters to kilometers. So we have 0.011 kilometers per second, and we have to convert that to kilometers per hour. So now look, we already did the first part. Now we just have the next half to do. So now we're going from seconds to hours. Yeah? Now, am I going from a small rate to a big rate, or a big rate to a small rate? And the answer is seconds is pretty small, and I'm going to something that's hours, which is much bigger. So therefore, I'm actually going from a small rate to a big rate. And if you want to go from small to big, we have to multiply. So therefore, 0.011 times it by 60 times it by 60. Now when we times it by the first 60, we just converted it to minutes. When we multiply by the second 60, that's when we got it to hours. So our final answer is going to be 39.6 kilometers per hour. Okay, so in this part of the video, we're going to be talking about unitary method. Now, this is my all-time favorite method to use, especially when it comes to majority of ratios and rates problems. I always find myself using this method a lot of the times, about 90% of the times, to solve the questions that I'm dealing with. So let's have a look at what it is. Basically, the unitary method is finding one unit. So let's have a look at an example of unitary method type of question. Example number 1, part A. How many can he deliver in 1 minute? So we now know that Tom can deliver 20 parcels for every 10 minutes that he has. So 20 parcels in 10 minutes. So for example, in 20 minutes, he'll deliver 40 parcels. So we'll just multiply that by 2. But the question is asking, how many can he deliver in 1 minute? So in other words, now the question wants parcels per 1 minute. And you got to ask yourself, well, how do I go from 10 minutes to 1 minute? What do? Do I times? Do I divide? And look, logic comes into this a lot of the times, and this is especially one of the topics that it's going to build your logic reasoning skills. I truly believe that. Especially when you dissect the question and when you break it down, you're going to see how logical things are going to be progressing. So 10, to get that down to 1, we're going to be dividing by 10. So therefore, what am I going to do with this 20? I'm also going to be dividing by 10. So now 20 divided by 10, that gives us 2 parcels every minute. Okay, now part B. How long will it take Tom to deliver 30 parcels? Now this could be a little bit tricky, and I want you guys to really understand what's happening. We now know that Tom can do 2 parcels every single minute. So the first way we can do it is if Tom delivers 2 parcels every single minute, well, if I want to know how long it will take Tom to deliver 30 parcels, well, why don't I find out how long it's going to take Tom to deliver 1 parcel? So, how do I go from 2 parcels per minute to 1 parcels? Well, I'm just going to be dividing that by 2. Again, I'm using the unitary method. So, I'm going to be dividing by 2. And now look at this. If that was 1 minute, divide that by 2 as well. Now 1 minute divided by 2, we're going to get 0.5 minutes, or you can even think about it as 30 seconds. But just to keep things simple, I'm just going to put 0.5 minutes. So let's rewrite this out again nicer. 1 parcel every 0.5 minutes. Now, let's go back to the question. It says, how long will it take Tom to deliver 30 parcels? Now, if 1 parcel takes half a minute, all I gotta do is I have to just multiply this by 30, because I need to know how long it's gonna take me to deliver 30 of these parcels. So now from here, I'm just going to be timesing by 30. So you can write it out as I have set it out before. So 1 parcel is equal to 0.5 minutes. Therefore, 30 parcels will equal to 0.5 minutes times that by 30 as well, and that's going to give us 15 minutes. Okay, so let's go into something that's a little bit more difficult. Example number 4. Maya's car uses 9 liters of petrol to travel 100 kilometers. So in other words, 9 liters would get you 100 kilometers of distance in your car. Now petrol costs $1.50 per liter. So every time I want to get 1 liter of petrol, that's going to cost me $1.50. If I want 2 liters of petrol, that's going to cost me $3. If I want 3 liters of petrol, that's going to cost me $4.50, and I can just keep going on and on and on and on. Part A, it says, what is the cost of traveling 100 kilometers? Okay, now before I get stuck into the question, let's analyze what the question's saying. It's saying Maya's car uses 9 liters of petrol to travel 100 kilometers. So that means 9 liters equals to 100 kilometers of distance. Now we also know that petrol costs $1.50 per liter. So $1.50 per is equal to 1 liter. Now part A says, what is the cost of traveling 100 kilometers? Now let's have a look at the facts. Every liter that I use, that's going to cost me $1.50. So like what I was saying before, if I was to use 2 liters, well, that's just going to be $1.50 times 2. If I was to use, 5 liters, that's going to be $1.50 times it by 5. Now the question wants us to travel 100 kilometers, and we know 100 kilometers, the car uses 9 liters for every 100 kilometers. So that means I need 9 liters. So what I'm going to do is I'm going to do $1.50 multiplied by 9, because I need 9 of those. And that's going to give me $13.50. So in other words, if I was to fill up the car, or Maya's car, if I was to fill up Maya's car, and I stopped the petrol gauge exactly at $13.50, I now know that that's going to take me 100 kilometers. Okay, let's have a look at part B. How far can she travel using $50 worth of petrol? Okay, now we've got to be working backwards a little bit, because the question's asking, it's not asking about how much it's going to cost you, it's saying she only has $50 to spend. So let's break this down now. So remember how in the question it said that $1.50 would equal to 1 liter. Well, the car goes on how many liters of petrol, available. So I need to know how many liters of petrol would I be able to get for $50. So now a visual representation of this would look something a lot like this. Pretend this is my $50 right there. And I want to know how many $50s can I fit into this $50? So can I fit in 1? Can I fit in 2, 3, 4, 5, 6, so on and so on and so on and so on. So what I'm going to be doing is I'm going to go $50 and I'm going to divide that by $1.50. And the reason why I'm dividing is because, like what I was saying before, I want to know how many $50s can fit into the $50. And that's going to give me 33.3 repeater. So now let's have a look at the facts. So since $1.50 is equal to 1 liter, I now know that $1.50, I can fit into it, the $50, I can fit it in 33.3 times. So that means that now $50 would actually get me 33.3 repeater liters. So now that's what I have right there. Okay, cool. But that's not what the question's asking. The question's asking, how far can she travel? Now, if you guys remember, 9 liters of petrol, that'll get us 100 kilometers. How far would I be able to travel with 1 liter? So now this is just another application of the unitary method. So from 9 liters, I want to know 1 liter. So we would have divided that by 9 and therefore divide the kilometers by 9 as well. Okay, now things are getting a little bit messy. So let's write down everything that we have so far. So we now know $50 is equal to 33.3 repeated liters. And we also know that 1 liter of petrol will get us 100 over 9 kilometers. So that's just some distance that will get us. Okay, now the question says, how far can she travel using the $50? Well, have a look at this. 1 liter will get us this many kilometers, and we need 33.3 repeater of those. So if you want just to round it off, not that we should, we just need 33 of those liters. So what I'm going to do is, if 1 liter is equal to 100 over 9 kilometers, how many liters would I get with 33.3 repeated? And we would have to multiply by 33.3 repeater, which would equal to 370.3737. That just keeps going. So that's how many kilometers I'll be able to get with the 33.3 liters. But because the question says answer to the nearest kilometer, I just have to round this guy up to the nearest kilometer. So the final answer would be 370 kilometers. Okay, so on to example number 5. A plane traveled non-stop from Iceland to Sydney, a distance of 23,572 kilometers in 16 hours and 20 minutes. So far we have 23,572 kilometers is equal to 16 hours and 20 minutes. Now, what I like to do is have all of this, the right side, as the same unit. So say the 16 hours and 20 minutes. We want to convert that whole thing in terms of hours. So that's going to equal to 16 and 1/3 hours. And basically the simple way that you could do that is just 16 hours, that's 16 hours clear cut on the side, and then you have 20 over 60 left. And then when you simplify this fraction, it gives you 16 and 1/3. So in other words, 16 and 1/3 hours is exactly the same thing as saying 16 hours and 20 minutes. The plane started with 290 kiloliters of fuel. So we know that 290 kiloliters of fuel, and on landing had enough fuel to fly over another 35 minutes. So what this means is that the fuel that they filled up with initially, that took them the whole journey. But when they landed, they realized, hey, we can go another 35 minutes. So in other words, to use up this whole 290 kiloliters, they must have done the 16 and a third hours of travel, which they did, plus another 35 minutes. So all up, this is going to come to 16 hours and 55 minutes. So if I was to write this now as a fraction, just to make things a little bit more simpler, we're going to get 16 and 11 over 12 hours. So in other words, the whole amount of fuel, right, could have been used up in 16 and 11/12 hours. Okay, part A. What was the plane's average speed in kilometers per hour? Answer to the nearest kilometer. Okay. So remember how we said that the distance between Iceland to Sydney was 23,572 kilometers, and they did this distance in a matter of 16 and a third hours. Now the question wants us to go, so what we have so far is 23,572 kilometers is equal to 16 and a third hours. Now they just want us to go to kilometers per 1 hour. That's what they really want. And now this is coming back again to the unitary method. If you notice, see this part over there, the 16 and a third, that's got to come down now to 1 hour. And the way we do that is divide it by itself. So an application of the unitary method. So to go from 16 and a third to 1, if we had to divide that by 16 and a third, I need to do the exact same thing to this side over here. So it's going to become 23,572 divided by 16 and a third. So our final answer would be 1,443 kilometers per hour. Alright, so part B. How much fuel was used? Okay, so now remember how we started off with 290 kiloliters at start. Once we did the journey of 16 and a third hours, we still had another 35 minutes to go. If we did travel another 35 minutes, that means we would have used up the whole entire 290 kiloliters of fuel. So what that means is, and look at this, right before we started, right before we got stuck into the questions, we just did a bit of an analysis over here. And that's what I like to do every single time I do a question. I would always write down all the important information, digest it, analyze it, do as much as I can. Then I would start reading the question. So far we know, just looking at this, 290 kiloliters, that would get me 16 and 11/12 hours. Now, that's the whole thing, but I don't want the whole thing. I only want to know how much fuel I used. And the time it took for me to use that amount of fuel is going to be 16 and a third hours. So that's what I need to get to. So just to write it down again, 290 kiloliters is equal to 16 and 11/12 hours. Now remember, I need to get to 16 and a third hours because that's how long I traveled for, therefore that must be how much fuel I used. So another application of the unitary method. Now you can divide both sides by 16 and 11/12, and you would get 120/7 kiloliters for 1 hour. So anytime you divide a number by itself, that always gives us 1, so that always checks out. You just have to make sure you put this in your calculator properly, and that should give you the right answer. Okay, now if that was for 1 hour, remember the journey only took 16 and a third hours. So now I have to multiply all of this by 16 and a third. So therefore 120/7 multiplied by 16 and a third, and that'll give us 280 kiloliters. And that's going to be our final answer right there.